Come to module 16. This is our very last module for Math 108. So in this particular section, 16.1, we're going to talk about solving quadratic equation using definition of square root. So basically, the three section we have in module 16 is about solving quadratic equations. So we did learn how to solve quadratic equation back in module 13. And the method that we used was solving by factoring. Okay, so for basically for the problems for the quadratic equation that cannot be factored, in 16.1, 2, and 3, I will show you other alternative ways. All right, so quadratic equation, as you can recall, has a standard form: ax squared plus bx plus c equal to 0. The most fundamental way solving quadratic equation is by factoring. And I know my equation is quadratic because the exponent is to the second power in the equation. Or you can say the degree of the polynomial is 2. All right, so before we just solve it by factoring because those problems were factorable. So when we run into problems that are not factorable, then we can use the technique called the square root property. Another way is called by completing the squares, or something called solving by quadratic formula. Now in Math 110, our college algebra course, we will show you how to solve quadratic equation by graphing. All right, so this section is about square root property. Square root property for quadratic equation is designed for equation that consists of two terms. Okay. Completing the squares and quadratic formula, both of them is designed for quadratic equation that are three terms, such as the ax squared plus bx plus c form. Okay, that's the form. All right, so exactly what is a square root property? I actually mentioned this back in module 15.1 when I was mumbling something about when we have a square root of 64, we can rewrite the 64 as 8 squared or negative 8 whole thing squared. So basically, in other words, if I have a square root of something that is equal to 8, then that x or that something inside the square root can be either rewritten as 8 whole thing squared, or it can be rewritten as negative 8 whole thing squared. So they tell me that the principal square root, okay, the answer should be positive or it can be negative. Just like here, if I have a square root, if I have an x squared equal to a constant c, okay, this c can be positive or negative. When I take a square root on both sides, this x in here technically can be a positive or negative. So that means when square and square root cancels out, my answer should be either positive or negative square root of c. That's why the positive negative sign is actually right in front of the radical. All right. If my quadratic equation looks in the form of x minus a whole thing squared equal to c, technically this form we only have two terms, just like the x squared equal to c. So whenever I got two terms, I can simply take a square root on both sides. So that means every time when we take a square root on both sides, the answer will always come out to be a positive and a negative square root of my constant. All right, then the textbook also shows that then to get x by itself, I will simply move this term to the other side and we will place it right in front of the plus and minus. Okay, so what does a plus and minus mean here? Plus and minus means I actually have two answers. Okay, one of them is going to be a plus square root of c. The other answer will be a minus square root of c, because when I take a square root, my answer should be positive and negative. So that means I should have at most two answers. Okay, and I'm purposely saying the word at most two answers because there are times where when we're solving quadratic equation, my answer will only be one solution. And we will explain that more of that in detail in college algebra. All right. Now, if C, this number C on the other side of the equal sign is a negative, then the solution will be non-real number. And we will actually take a look at that in a minute. All right, so let's give this a try, okay? X squared equal to 40. So this is a quadratic equation. I actually cannot factor out 40 if let me put it right here on the side. If I will move the 40 back to the other side, make it into a negative 40, x squared minus 40 is actually cannot be factored, okay? So now we can use our square root property. So once I isolate my x squared term, then I can simply take a square root on both sides. So square and square root cancels out. My x will simply equal to a positive and a negative square root of 40. All right, so now all I need to do is simplify my square root of 40. So I'm going to break down 40 here on the side real quick using prime number 2. Go into it 20 times, 2 go into 20 10 times. And 10 is only made out of 1, 2, and 1, 5. All right. So since I'm dealing with square root, I'm looking for 2 the same number to go outside. So those two 2's will go outside as one of them. The other 2, 1, 2, and 1, 5 stays inside. Multiply becomes 10. So my answer, x equal to positive and negative 2 times square root of 10. So when we enter our answer, okay, sometimes it will ask us to write them. Sometimes you will ask us to write them, put them in 2 boxes, okay. The 2 boxes indicating I got 2 different answers, and you might also see a little brace on the outside of the box. What that indicating is we will write our answer in the set notation. So I'm going to purposely rewrite my answer as 2 of them. So my answer is, okay, put in the set notation with the brace. That would be negative 2 times square root of 10, comma. The other answer is positive 2 times square root of 10. Okay, we will put them in the solution set. Okay, so just in case if you ever see the brace that's outside the box, that's the reason why they want us to write the answer out as in set notation, in the solution set. All right, this problem is very similar to it, except now I actually have a 5 in front of my leading term, y squared. So what I can do to isolate my y squared, I can go ahead and divide both sides by 5. So that will give me y squared equal to, let's see, 175 divided by 5, 35. So as you can see, if I move my 35 over, I really can't factor y squared and negative 5. So here we can use our square root property. As long as I got 2 terms, I can always use square root property. Take a square root on both sides. Square and square root canceled out. That will be y equals. The answer is always, please do not forget, the answer is always going to be positive and negative square root of 35. 35 cannot really be broken down because 35 is only 1, 5, and 1, 7. So neither 1, 5, and 1, 7 can go outside the square root. So my answer would just be, put in the solution set will be negative square root of 35, comma, positive square root of 35. All right. Now this problem, x squared plus 121. Please don't mistaken this as x squared minus 121. If it's x squared minus 121, that becomes a difference of squares, where we can actually factor it as x plus 11 and x minus 11 equal to 0. But this 121 is positive, not negative. Okay, so it's not the same type of problem. So by having a positive sign in front of 121, that actually make this x squared plus 121 not factorable. Not factorable is not the same thing as can't solve it. we can actually solve it. We just cannot solve it by factoring. So since I only got two terms, the way we solve it is by isolating the x squared term. So I'm going to move my positive 121 to the other side so I can get x squared equal to negative 121. So here, when we take a square root on both sides, you got to actually make sure this negative sign goes inside the square root. Just like right here, it says if c will be a negative number, then the solution will be non-real, because now when I say square and square root cancels out, my answer would just be my answer would just be an x. That will be x equals square root of 121 is 11, but the square root of that negative is going to be 11i. And again, when I take a square root on both sides, my answer should always be positive and negative. Okay, so write my answer as in solution set. That will be negative 11i, comma here means separating my two answers, and the other answer is positive 11i. Okay, so majority of times when we take actually every time when we take a square root on both sides, my answer should be positive and a negative. Okay, so here I got negative 11i and positive 11i. I'll try another one, okay? And I do want y'all to see these answers so far, all the answers we come up with so far, even though there's two different answers, each answer only consists of one term, okay? When we get to module 16.3, we will actually have multiple terms, just like this form. If my problem looked like this form, okay, then this answer, even though I got two of them, it's actually two separate terms. All right. And when you do your homework on the Hawks Learning, you will notice a lot of these problems are very repetitive. That's why I'm only going to do a few of these, not a bunch of them. All right, again, two terms. I'm going to move my positive 75 over. So instantly, this is going to be y squared equal to negative 75. All right, so let's take a square root on both sides. I want to take a square root on both sides. Square and square root cancel out, so that leaves me with my y equals positive and negative. All right, let's break down the 75. Let's see if this square root 75 can be broken down here on the side. I'm going to use a 5. 5 going to 75 about 15 times, I believe. And 15, I can use another 5 to go into it 3 times. 3 is a prime number. Only 3 can go into 3 one time. So these two 5s will go outside as one of them. So that will be positive negative 5 times square root of this 3 got to stay inside. All right. This negative sign inside the square root will give you my non-real number or imaginary number. So make sure this I is on the outside the square root. So my solution set, my answer, negative 5 times square root of 3i, comma, positive 5 times square root of 3i. So sometimes you will notice the I can be written right between the 5 and the square roots. Okay, that's okay. If you want to put it on the back side, make sure your cursor is on the outside of the square root before you enter the I. All right, let's look at this one, okay? So this one looks just like in the form of x minus a whole thing squared equal to c. So most students were actually trying to multiply this out. So this thing on the left side looked just like a perfect square binomial or perfect square trinomial. A plus b whole thing squared equal to a squared plus 2ab plus b squared. Okay, so if you want to multiply it out, you can, but that will actually cost a lot more work. So while there are two terms, and my square term is already by itself, so I'm just going to simply take a square root on both sides, because square and square root cancels out. That would just leave me with 2y plus 12. I'm not even going to write a parenthesis, because now the parenthesis will serve no purpose, since there's no other numerical number in front of the parenthesis, and there's no more exponent other than 1. So having a parenthesis to the first power is really no need for that. So I'm just going to write 2y plus 12 equal to positive and negative square root of 48. So let's break down this 48 here. I'm going to use 2. I could have used 3. I'm going to use 2. That will be 24 times. 2 will go into 24 12 times. 2 will go into 12 6 times. And 2 will go into 6 3 times. 3 can only go into 3 1 time. So these two will go outside the square root as one of them. These two will go outside the square root as another 2. So 2 on the outside simply means 2 times 2 is 4. So this 3 will stay inside. So far there will be positive negative 4 times square root of 3. The other side, 2y plus 12. All right, so where do we go from here? Well, I will need my answer to be y equal. So now I'm going to move this term to the other side of the equal sign. And I'm going to purposely place it right in front of the plus and minus. So my answer will look like 2y equal to negative 12 plus minus 4 times square root of 3. Now these two are not like terms, okay, because this has square root of 3 with it. The negative 12 don't. So now divide both sides by 2. And I'm purposely saying divide both sides by 2 because I can actually write my answer as negative 12 plus or minus 4 times square root of 3, whole thing over 2. All right. Now, before I put this answer in, we need to simplify this fraction a little bit. The only time you were simplifying a fraction in this looks like this is when all the terms or all the numbers on the outside the radical can be reduced. So since negative 12, the 4 and the 2 can all be reduced by 2, that will give me negative 6 up here, 2 right here where the 4 was, 1 down here. So my answer now is simplified into negative 6 plus minus 2 times square root of 3 over 1. But since it's over 1, we can actually not write it as over 1. So these two terms on the numerator is technically my answer. Okay, that's a simplified answer. If you write it as over 1, that would just be redundant. So in the solution set, I can say my answer is negative 6 minus 2 times square root of 3. And I always put the small answer up front. The minus 1 is going to be smaller than the plus 1. And the other answer is negative 6 plus 2 times square root of 3. So so my two answers, okay, each one has 2 terms, okay? Versus other ones only have 1 term in the answer. All right, let's look at this one. So this one I have a 2 times in front of my parenthesis. So what I'm going to do, since I only got 2 terms, what I'm going to do is go ahead and divide both sides by 2, because that will allow me to get rid of the 2 that was in front of my parenthesis. So now my square term, y minus 2 whole thing squared, is isolated, equal to, let's see, 150 divided by 2, I think it's 75. Sure is. All right, now I got 2 terms, so I can take a square root on both sides. So square and square root cancels out. That just leave me with y minus 2 equals. All right, when I take a square root on both sides, my answer is always positive, negative. So I'm going to go back up here and see what the 75 was. 75 was ended up to be 5 times square root of 3. Just no I here because my 75 was a negative. 5 times square root of 3. Because 75 can be using 5 to break it down. What was that, 15? 5 again is 3. 3 going to 3 1 time. So these two 5s will go outside as 1. The 1 3 stays inside. So now to get y by itself, since I got 2 terms on the left, I'm just going to move my negative 2 over. So that will be y equals, negative 2 come over, become positive 2, plus or minus 5 times square root of 3. So in my solution set, I should have 2 minus 5 times square root of 3, comma, the other answer, 2 plus 5 times square root of 3. All right, so in this lecture video, we talked quickly about how to solve quadratic equation only consists of 2 terms, okay? Basically, we use the square root property where we can take a square root on both sides. It's just when these type of problem looks like a perfect square binomial trinomial on one side equal to another constant or another number on the other side, it's still considered as two terms, so we can quickly just take a square root on both sides and then simplify our answer. All right, that will conclude this lecture video. Thank you for watching.